So we'll have a brief glimpse of the atomic structure. The notion of atomic structure dates back to the days of Rutherford, when he proposed his famous atomic structure based on the notion of a solar system. So Rutherford basically performed an alpha ray scattering experiment, based on which he understood that most of the space in an atom is empty, and the electrons which are negatively charged revolve around the nucleus in orbits, and the positive charges are basically concentrated at the center of the atom in a space called nucleus. And while performing his alpha ray scattering experiment, he found that most of the alpha particles pass through the gold foil, and a very small fraction of the alpha particles were deflected by small angles. However, 1 in 20,000 alpha particles touched the gold foil and then bounced back with a velocity that is greater than the velocity with which it was targeting the gold foil. So immediately he came to the conclusion that there must be some center of positive charges. So Rutherford noticed that 1 in 20,000 alpha particles were targeted, which were approaching the gold foil, came back with a velocity greater than the velocity at which it was targeting the gold foil, and therefore he came to the conclusion that there must be some positive charge at some points in the gold foil to which the alpha particles were approaching, and then came because they were strongly repelled by those positive charges, they came back with a velocity greater than the velocity with which it was approaching. And immediately he basically proposed for his atomic structure based on the notion of a solar system, where just like the sun located in the center of the solar system, here you have the positive charges located in the center of the atom called nucleus, and then electrons equal in number to the number of positive charges in the nucleus revolve around the nucleus in circular well-defined orbits. However, with this concept works well as long as the particles are neutral, because it is well known from the classical theory of electrodynamics that if a charged particle revolves around the electric field of another charged particle, then the revolving charged particle gradually emits radiations, loses energies, and falls into the other charged particle. And however, in case of an atomic structure, we know that the atomic structure is fairly stable, and therefore this kind of polarizations do not take place. Therefore, there must be some flaw with the Rutherford's atomic model, and this was actually corrected by Niels Bohr, who is basically Rutherford's student, who basically propounded that the energy of an electron in an orbit remains unchanged as long as the electron remains in that orbit. Hence, these orbits are called stationary orbits or stationary states. The energy, the key features of Bohr's model comprises of energy of electrons are emitted when electrons move from higher energy level to a lower energy level, or in other words, higher stationary state to a lower stationary state, and energy are thus released in the form of radiation appears in the form of packets of energy or quanta of energy. If the energy in an outer orbit of an electron is E2 and inner orbit is E1, then the change in energy is E2 minus E1, which is emitted as a quantum of energy. The angular momentum of an electron is quantized, whose angular momentum is an integral multiple of h by 2 pi, where h is the Planck's constant. So the notion of electrons moving within an atom cannot be explained by classical mechanics, because there are lots of aspects of electronic behavior which could only be explained with the help of quantum mechanics, which is a theoretical science that deals with the study of motion of microscopic objects that have both observable wave and particle-like properties. So previously Davison and Germer they showed an excellent experiment where they could show the diffraction of electrons, but it was very well known that diffraction is a property that can only be exhibited by waves and not by particles. But since waves and particles are both showing diffraction, therefore it was Louis de Broglie who made the famous hypothesis of wave-particle duality of matter. And naturally, the next question came up, how to develop the notion of these matter waves, and that was actually given by Erwin Schrödinger in his famous Schrödinger's wave equation, where which was basically built on the notion of Heisenberg's uncertainty principle. For a particle, subatomic particle moving with very high velocity, it is almost impossible to predict the position and momentum at the same time, and therefore, in order to bridge between the Schrödinger's bridge between the Heisenberg's uncertainty principle and the Bohr's atomic model, it was proposed that instead of moving in orbits, there are well-defined spaces called orbitals where the electronic motion is restricted to electrons can exist at any point within an orbital. So instead of just having a principal quantum number which basically describes the size and energy of the orbital, they came up with the notion of azimuthal quantum number. Then apart from this azimuthal quantum number, under a strong magnetic field, people found that the spectra of the atoms showed some closely spaced lines, which means that different orbitals will have different magnetic moments, and this led to the notion of magnetic quantum number. And finally, under the influence of weak electrical field, they again showed further splitting of the lines that were split with the help of strong magnetic field, and this led to the notion of spin quantum number, with each electron having spin up or spin down states. So the study of solid state structure reveals that there are three different types of primary bonds. The one is the ionic bond, in which there is an electrostatic force of attraction between the positively charged ions and the negatively charged ions. There is a covalent bond, which basically is formed by the sharing of electrons between two atoms. And the third type of bond is called the metallic bond, where the valence electron is shared throughout the metal. So energy gap exists between the valence band and conduction band. The valence band is the highest range of energies in which the electrons are present at absolute zero temperature. So for example, lithium has an electronic configuration of 1s to 2s1. The highest energy state field at absolute zero temperature is 2s. So these energy states form valence band. The unfilled energy orbital with no electrons, that is 2p orbital, in this case corresponds to conduction band.